This is my bonding project on SF4 and CO32-. The Lewis dot structure of SF4 looks like this, with 4 bonds and 1 lone pair. The VSEPR formula is AX4E, which means on the central atom there are 4 surrounding atoms and 1 lone pair. The 4 surrounding atoms are fluorine, and there's 1 lone pair on sulfur. The molecular shape is a seesaw. This is because the lone pair, here, is pushing down on these bonds, creating a seesaw shape. The bond angle is a little less than 120 and 90 degrees. On a regular trigonal bipyramidal, the bond angles are 120 and 90, but because of the lone pair, it pushes down on these bonds, creating it less than 120 and 90 degrees. The bond polarity. Sulfur is partial positive and fluorine is a partial negative. Because fluorine is a partial negative, it's going to be more polar than sulfur, causing the electrons to pull towards F. The hybrid orbitals are the X and E from the VSEPR formula. You add them together and distribute them between S, P, D, and F. S gets 1, can hold 1, P can hold 3, and D can hold 5. So 4 plus 1 equals 5. S can hold 1, so that gives us 4. P can hold 3, minus 3 equals 1, and we have 1 more, which goes in the D. The sigma bonds and pi bonds are 4 sigma bonds and 0 pi bonds. Sigma bonds are the single bonds here, 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 and here. And pi bonds are the resonance bonds or the double bonds, which sulfur SF4 does not have any. The intermolecular force is a dipole-dipole. The intramolecular force is covalent because the 2 bonding atoms are both nonmetals. The formal charge is 0. This is because in a formal charge, you do the number of valence electrons, so S has 6, and you subtract the number of bonds, which is 4. So 6 minus 4 is 2. And then you subtract the number of unbonding electrons, which is these 2. So S will equal 0. Fluorine will have 7 valence electrons, but because there are 4 of them, you need to multiply by 4. So 7 times 4 is 28. Then you subtract the number of bonds, which is 4, so you come to 24. Then the number of unbonding electrons, 6 here, 6 here, 6 here, 6 here, which is 24. And 24 minus 24 is 0, so the formal charge is 0. There are no resonance bonds because they're all single bonds. A resonance bond would be when it's an incomplete octet and you have to have more than 1 bond for the atom. This is an expanded octet because it has a lone pair here instead of just 8 on the outside of sulfur. There are 10. The bond order is 1. This is because in a single bond, the bond order is 1. It's a nonpolar bond because the dipole moments toward F cancel each other out. Because there are 4 right here, they cancel each other out, which was shown in the bond polarity. The Lewis dot structure for CO32- looks like this, with 3 regular bonds and 1 resonance bond. The VSEPR formula is AX3, which means on the central atom there are 3 surrounding atoms. The surrounding atoms are oxygen and the central atom is carbon. The molecular shape is a trigonal planar, which looks like this. The bond angle is 120 degrees, which means that between this oxygen and this oxygen, it's a 120 degree angle. The bond polarity looks like this. Carbon is a partial positive and oxygen is a partial negative. This is because oxygen is more electronegative than carbon, causing the electrons to pull towards O. The hybrid orbitals are sp2, which is found by adding the X and E from our VSEPR formula. We have 3. You distribute them to S, P, D, and F. S can hold 1, P can hold 3, and once we give 1 to S, we have 2 more to give to P. We have 3 sigma bonds and 1 pi bond. A sigma bond are these single bonds here, and the pi bond is that extra bond right there. The intermolecular force is a London dispersion. The intramolecular force is covalent because it's two nonmetal atoms bonding. The formal charge of carbon is 0 because you take the number of valence electrons, 4, and subtract the number of bonds, also 4, giving us 0. Then you take O and take the number of valence electrons, 6, minus the number of bonds. On here, it's 1, giving us 5. Then you subtract the number of non-bonding electrons, which is 6, giving us -1 here, which is the same for this one, also giving us -1. On this one, you have 6 minus 2 because there's 2 bonds, giving us 4, minus 4 because there's 4 non-bonding electrons, giving us 0, making it a formal charge of -2. There's 3 resonance bonds because this extra bond could go on any of these bonds. It's an incomplete octet because we had to do a resonance bond, having to make it 8 surrounding the central atom. The bond order is between 1 and 2 because on a single bond, the bond order is 1, and on a double bond, it's 2. We're in between 1 and 2, making us the bond order between 1 and 2. It's a polar molecule because the dipole moments towards O do not cancel each other out. Net pole is going down. This is a model of an SF4 atom. The molecular shape is a seesaw. It has a fluorine atom here, 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 and here, and the central atom is sulfur with a lone pair on top. This is a model of a CO32- molecule. Central atom is carbon, and the 3 surrounding atoms are oxygen. It's a trigonal planar shape.